So after a Kingdom Come Deliverance 2, which was rather well optimized a few days ago with a CryEngine which always does the job, we continue today with Monster Hunter Wilds with its re-engine. And well, it won't be the same. So let's see how it goes. Right after the sponsor, here we go. So, a small change which is not really one for the channel's sponsor. You surely know Godil24, who has been supporting the channel for almost 2 years now. And now, we're switching to KissFan, which is another site from the same company, but it's exactly the same thing. We therefore find the classics as well as the same promo codes and reductions with the keys. Windows 10 Pro for under $9, and Windows 11 Pro keys for less than $14 with the channel code VCG50. And for Office keys or Windows Plus Office packs, you get a 62% discount with the code VCG62. Regarding payment, the process is explained at the bottom of the offer page, which will allow you to choose your payment method by card or PayPal. And when you receive the keys by email with instructions on how to use them, don't forget to check that the email is not in your spam folder, just in case. If you encounter any issues, don't hesitate to contact customer service, which is available 7 days a week, 24 hours a day, and will assist you as quickly as possible. All the links are in the video description, and as usual, thank you if you buy a key, because it allows you to support the channel, which largely survives thanks to this partnership, while getting something in return. So a big thank you to you for your support, and to KissFan, who sponsors this video. So Monster Hunter World is the latest episode in the series. Monster Hunter, a game about hunting big monsters either in co-op or solo, with a mix of RPG elements. It's developed by Capcom, and compared to Monster Hunter World, which was the last major installment in the series and was running at the time on a proprietary engine from Capcom, the MT engine. So we're now moving on to Capcom's latest engine, the re-engine, for this new episode. And it's true that Capcom's approach to engines kind of reminds us of what happened back then. At one point in time, with the Electronic Arts, who were absolutely determined to use Frostbite in almost all their games, with more or less success, it's a bit the same here. The re-engine is used in the latest Resident Evil, Street Fighter 6, Dragon's Dogma 2, or even a bit older with Devil May Cry 5. And it's true that the whole monster works really well and even feels quite light in some titles. Pretty compartmentalized, like Resident Evil 4, Remake, Resident Evil Village, or even Street Fighter 6. In contrast, we already saw last year that in an open world like Dragon's Dogma 2, the engine was still much less comfortable. The management of the main city in the game was pretty disastrous, especially at launch. It has been somewhat improved, but it's still not amazing. And it's true that overall, in Dragon's Dogma 2, the performance in terms of what's displayed on screen is still quite mediocre. The scaling of the graphic presets and upscalers wasn't great either. So, well, that did suggest that the engine might not be the most suitable for open world type games. Or maybe Capcom didn't handle things well either with Dragon's Dogma 2. Some even considered that Dragon's Dogma 2 was serving as a bit of a real-world test, let's say, for Monster Hunter Wilds in terms of the open world. And it's true that during the first playtest of the game we noticed that for Monster Hunter Wilds we were heading towards something quite similar to Dragon's Dogma 2. In terms of behavior and hardware requirements, it was really heavy for the final result on screen. And it's true that just a few days before the game's release, Capcom put an online benchmarking tool, which is a really good thing, and it's something I think a lot more publishers should do this, whether in the form of a demo, just like we had with Final Fantasy XVI, or benchmarking tools like this one, or with Blackmate Wukong a little while ago. It gives you an idea of how the game will run on your machine and whether it's worth buying or not. So it's this benchmarking tool that I use for today's tests. The benchmark sequence is a mix of cutscenes running on the game engine, as well as exploration sequences in the game world, which look a bit more like gameplay sequences. And clearly the cutscenes are lighter than the few gameplay sequences, which will surely be more representative of the final performance. So, we're going to take a look at some benchmark sequences on the different cards. In the video, during the heavier sections, the performance charts will be made based on the entire benchmark. So, that's something to keep in mind when we look at all this, since the benchmark as a whole allows us to see or manage the differences between the various cards, but it won't be representative. I would say the most demanding sections of the title, which we'll see in the video, and for the PC version of the title, at launch we have a shader compilation sequence just like it was the case for Dragon's Dogma 2, by the way. In terms of the menus, well, it's not the most user-friendly, I think, but it was never really Capcom's forbidden at that level. We do have support for ultra-wide HDR in terms of upscalers. We have DLSS 3, FSR 3.1, and XeSS 1.3, as well as frame generation for AMD and Nvidia. By the way, the title At launch, it really emphasizes that you should use frame generation to get a good frame rate, which is immediately not very reassuring, and clearly we will quickly see why Capcom insists so much. On the other hand, it's good to have put the FSR 3.1, but if we can't use AMD's frame gen with DLSS or XSS like FSR 3.1 normally allows it, it's still a bit of a shame for owners of RTX 3000 or 2000 or Intel cards, or even for cards. Finally, for those who have an AMD card, if you want to use XCSS with FSR frame gen, then it's not possible. Well, I admit I didn't really understand why this blockage here. And we'll also see if Nvidia will add support for the new DLSS 4 upscaling model on the title with the Envy app. And from the first rounds I've seen for those who added this by hand, this one produces rather good results visually speaking on the title. So, I hope that this will be the case. It's worth noting that the TAA in the title is really bad, and it creates a rather unpleasant blur effect. And it's true that, visually speaking, overall, the comparison with Kingdom Come Deliverance 2 from a few days ago is quite funny, since it's true that in Kingdom Come, the characters and their animations were a bit outdated, but the environments, on the other hand, were pretty nice. Here it is a little bit on the contrary. The character models and animations are very well done, and all of that is very well done, even if the quality of the textures and all that on the armor, and from what I've seen, it's sometimes not amazing. It's true that on certain points it's a bit reminiscent of Final Fantasy XIV. I would even say that. But in terms of the environments of everything I've seen so far, it's not ugly. But it holds up. The AI is okay, but I would say that it's more the weight ratio of the title compared to what is displayed that poses a problem for me. Especially since, when scanning the game presets with a 5090 and 4K, we see that going from ultra details to the preset, at the lowest setting, we only gain 30% performance, 30% spread over a total of 5 presets. It's really not great, but you have to wonder why there are so many presets given the little impact they have on performance. And we can see that it's mainly going to the low detail mode that gives the biggest performance boost. And this one isn't too bad. By the way, the lowest detail mode, it does sting a little, and in terms of the upscaling, it's not great. No, since activating upscaling in quality mode only gains 25% in performance and roughly 10% more at each level, as is often the case. So it's true that right off the bat, the margins for improving performance without losing too much visually aren't that impressive. And we can already see that in native 4K, the most powerful graphics card in the world does not even reach 100 FPS on average. Here, so, well, yeah, that doesn't sound good. So we also find a ray tracing option on the title for reflections. In the demo, I would say that aside from a section with a little oasis with the water reflections, it hardly changes anything. And the impact on overall performance on the benchmark is almost totally transparent. It is too. So it was already a little bit the case on Dragon's Dogma 2. Ray tracing was not very greedy. But here it only concerns reflections. So not sure that ray tracing is mega useful on the full game either. But hey, it might depend on the biomes and all that. There might be places where there will be lots of reflections. I don't know, but well, on the benchmark. So I didn't test with ray tracing since it was pointless. So, and the impact on performance with almost all the cards was almost non-existent. So that's already the first takeaway. It doesn't start off very well overall, and before we dive into the performance details, there are a few points to clarify. The game is set to release on February 28th, and even if this benchmark might not use the code that will be used at release, I think it's already quite advanced. And if they provide a benchmark, it's supposed to represent the game's performance. If that's not the case, then it's pointless. So releasing a benchmark. The game also has level protection that we all love, of course. On the other hand, this one doesn't seem to be active in the benchmark, which allowed me to test all the processes without too much trouble. But then, if the level protection isn't active in the benchmark, maybe the game will run a little less smoothly once it's released, when it's activated. And clearly, we didn't need that on top of everything. But hey, we'll see how it goes. On top of that, I would say that the current drivers are not the day one drivers for the game. Maybe some small issues will be fixed. For the different brands, we'll see. But hey, I'm not really expecting any crazy upheavals, whether it's in terms of drivers or the game's performance. In a good way, let's say, in my opinion, it will still be quite close to what we're going to see here. Well, these are the latest drivers available for the 3 brands. I captured the performance on the entire benchmark, which allows us to have both the average frame rate and the 1%. Well, it's not perfect either, but from what I've observed regarding frame time, the changes in sequences and all that during the benchmark don't really seem to impact the average performance or the 1%. So anyway, let's take a look at all that. So we start with the RTX 5090 in native 4K at high detail. Well, it's not great. So I know this is one of the heaviest sequences in the benchmark, but I would also say this one probably represents more normal gameplay sequences. Here we're just wandering a bit in the wild. The rest of the benchmark is more like cutscenes, let's say, and it's still quite dramatic in terms of performance. The most powerful graphics card in the world right now can't even hit an average of 80 FPS here. Well, there's no ray tracing activated, and there's nothing exceptional displayed on the screen either. It's not ugly, but there's nothing that justifies handling such heaviness. So, well, it's not great. And if the 5090 was already struggling a bit, the 4090 and the 5080 under the same conditions definitely won't do any better. And as we can see here, both cards are below an average of 60 FPS. Still, a 4090 in native 4K that can't maintain an average of 60 FPS is almost unheard of until now, outside of games that had ray tracing cranked up to the max. So, once again, I'm okay with a game being very demanding, if there's a good reason for it, but here, honestly, there's nothing that justifies such heaviness. It's just complete nonsense. And of course, with cards that usually perform quite well, in native 4K most of the time, the 4080 Super and the 7900 TX, we can see that here, we're barely hitting 50. It was still quite dramatic. A small advantage for the 7900 XT overall. But whatever happens for the two cards, concessions will have to be made, additions will have to be made, upscaling will probably also require adding frame generation to achieve a level of performance that we should normally have without needing to activate all these technologies, so clearly it lacks optimization. So obviously for the 4110T and the 7900 XT it's even worse. And there I didn't even run the tests in 4K because it wouldn't have made any sense. But we can see that even here at 1440p, these cards should be performing much better than this in this type of game. Visually speaking, with this level of visual quality we achieve much higher scores than this in almost all other games. Here, we can see that the 410 Super is struggling to maintain an average of 60 FPS. The 7900 XT performs better, but it's not glorious either. I mean, it's 1440p. There's nothing amazing about it, and we're still quite far from 100 FPS in the heaviest sequence. And if we move on to the 410 Super and the 7900 GA, still at 1440p, we can see that we're not hitting an average of 60 FPS either. In the full benchmark sequence, we'll have better performance than this, but we can see that in a demanding scenario. We're not there. And it's still quite dramatic. Normally, this type of card performs much better under those conditions. And if we move on to the 4070 and the 7800 XT, which usually perform quite well in native 1440p, we can see that here too, we're under 50 FPS most of the time. Well, I won't spell it out for you. It's a little bit the same as from the beginning. It's way too heavy in terms of resource usage compared to what's being displayed. It's not coherent at all. And if we move on to cards more geared towards 1080p, like the 4600 with 8GB and the 7700 XT, here... So, we can see that the 7700 has an advantage. That's usually the case in most games, but we can see that we're not hitting an average of 60 FPS. At native 1080p, normally with the 7700 XT. No problem in the vast majority of games to achieve that. The 4060 Ti should also perform much better than this at native 1080p. So, even with this type of card, you will have to activate DLSS or FSR to have something playable and have a stable 60 FPS. It's still, well, there's still something wrong. Of course, with slightly less powerful cards like the 4060 and the 7600, we see that we're running under an average of 40 FPS. Well, as I've been saying since the beginning, it's really only in normal games with ray tracing and all that we have this type of performance. Here, we just can't achieve that. 30-35 FPS, sometimes a little bit more. In the lighter sequences, I think we might reach 60 FPS. But still, those are pretty miserable performances. If we move on to slightly older cards, the 3090 Ti and the 3080, 80 at 1440p. In 1440p, we see that it's not glorious either. The 3090 Ti doesn't even hit an average of 60 FPS at native 1440p. Well, this is nonsense. For the 3080 as well. And it's even slightly worse performance than the 4070 Ti Super. So I think the RTX 3000 series is underperforming compared to the RTX 4000 series, which is a bit strange. Maybe it's a driver issue. Perhaps it will improve with the drivers that come out with the game. Or maybe not. I don't know. But it's true that the performance is really bad. Once again. And with two other older cards, the 2080 Ti and the 6700 Ti, we're back to native 1080p. We can see that here too, the performance is dramatically low with 30-40 FPS for the 2080T and 45-50 FPS for the 6700 XT. Well, it's a disaster. And of course the 3060 and the RX 6600 are going to struggle, even more so because here we don't even reach an average of 30 FPS most of the time at native 1080p. Normally this type of card should be able to maintain 30 FPS in the vast majority of games. And we can also see here that the 6600 is maxed out in terms of VRAM, since we can clearly see there are little stutters, mini freezes and all that stutters. Here the VRAM is maxed out, so I redid the test on the card, at high detail still, but with the textures set to medium, and there it was running better. So we still don't have good performance, but now it's more about the VRAM being maxed out. But here too, we're going to have to make even more sacrifices to get something playable, and most likely go through scaling in quite an aggressive way, which won't look great on screen. In the end, for the Intel cards, the B580 and the 770, well, it's a bit the opposite of what we had in Kingdom Come. Deliverance, where the 770 performed better than the B580. Here, very clearly the B580 does better, but I want to say for the A770, I think there is a problem. At the driver level, maybe it's not very well opted for this one for the moment, since there, I think that the performances are still dramatically low. There is no reason normally to have such a gap between these two cards. So, in my opinion, it can do better than that, but even for the B580, it's not great, and its performance close to the 4060 and the 7600, which is pretty logical. Then we find the RTX 2060, so obviously a card with 6GB of VRAM. We see that on the left here. 1080p native, high detail. Well, it's complicated. The VRAM is maxed out. It's not running well. So I redid the test at low detail with DLSS in quality mode. It runs a bit better, but it's still not great. We're at 30-40 FPS. It's really not impressive because in the vast majority of games, normally the 2060 still manages to perform decently at 1080p. Sometimes you have to resort to upscaling and all that, but not as aggressively as here, so yeah, it's complicated. And finally, we wrap up with the GTX 1000 series, starting with the 1080 Ti, and it's a disaster here, once again. So, we already had some doubts about whether the game would run, since during the first phase of testing, the game required hardware mesh shaders. The game does launch with the 1080 Ti, but it's not running well. We're under an average of 20 FPS. It's almost unplayable, unless you do a really aggressive upscale. And still, we won't have good performance. So, if you have a GTX 1000, I think you can forget it. The game just won't run well anyway. I didn't even test the 1060 because I thought it wouldn't be worth it. If the 1080 Ti was already struggling this much here, and if we now look at how it goes with the graphics on the full benchmark, so there are some very heavy sequences like the ones we just saw in the video, and much lighter sequences. This means that on average it performs a bit better, as we can see here. But as we saw, it's not necessarily very representative of the sequences. I would say a little more gameplay, but still it allows us to see a bit of the trends. So, we can see that the 5090 is in the lead, which isn't a big surprise. However, the 4090 and the 7900 XTX are performing at a similar level on average. But when it comes to the 1% lows, the XTX is closer to the 5080. But we can see that it's a game where AMD cards seem to perform better compared to Nvidia cards. However, the performance isn't great for any of the cards, regardless. So of course it depends on the games. We saw that Kingdom Come Deliverance was more in favor of Nvidia. Here it seems more in favor of AMD, particularly for the 7900 XT and XT. The rest of the lineup is more standard, I would say, but still, it's not great for the majority of the cards. Just to remind you, here it's 1080p at high detail. We can see that the 4070 is barely reaching an average of 86 FPS, but we also see that the RTX 3000 series, as we saw in the video, is performing a bit worse than usual, since here the 3090 Ti is facing off against the 4070, and the RTX 3080 is below the 7700 XT. So we'll also see if there are any improvements for Nvidia cards in terms of drivers or not, but as it stands with the current tools, it's not looking good, regardless of the card. At 1440p, we're dropping down another notch. So I've removed all the cards that didn't reach an average of 30 FPS because it's just pointless. So while the 5090 on its own manages to maintain around 130 FPS on average, but still we're at 1440p native. Nothing incredible normally. The 4090 is starting to pull ahead a bit from the 7900 XTX, which still slightly dominates the 5080. On average, however, at the 1% lows, they are still almost at the same level. So we see, I would say, this advantage for the 7900 XT and XTX over their equivalents at Nvidia. For the rest of the lineup, it's a bit more standard, since we see, for example, that the 7900 GRE and the 4010 Super are tied, and the 4060 and RX 7600 are more or less at the same performance level too. We still see this performance deficit for the RTX 3000. Not much is changing here. And we can see that at the bottom of the table, the 3060 has an average of 33 FPS, while the B580 has 36. We can see that it's not impressive for Intel's card. It comes in below the 4060 and the 7600. At 3440 by 1440, well, it obviously becomes more and more complicated. The 5090 is the only one to reach over 100 FPS on average. The 4090 is still slightly ahead of the 7900X and the 5080 here. But we can see that the gap in average performance is also narrowing. However, in terms of the 1% lows, both cards are still tied, but still it remains an advantage for AMD with these two cards mainly. On the other hand, we see that the 7900 GRE and the 4070 Super are still neck and neck, as well as the 7800 XT and the 4070. It's very slightly the advantage of the 7800 XT, the 3080, 50 FPS on average. Well, it's getting complicated. And finally, at native 4K, well, the 5090 drops below an average of 100 FPS, while the 4090 is at 75. And the last card that comes in above 60 FPS on average is the 7900 XTX. And we can see that the 5080 is now slightly ahead. We had to wait until we were at 4K for that to happen. Well, in short, as we have seen from the beginning, whether in video or with the graphs below, it is quite dramatic in terms of performance. It is clearly nonsense. And so we come to the processor, and there too there are still things to say. Well, first of all, the game is very, very greedy. Once again, even on the processor side, we see that the 9800X3D comes out on top, followed by the 7800X3D. The Ultra 7 from 165K comes in just slightly above the 14700K, but we can say it's almost equivalent, or the 5800X3D performs quite well on average, but in terms of the 1%, it doesn't do as well, for example, compared to the 13600K or the Ryzen 7000 and 9000, which are below here. Interesting to see also that the Ryzen 7 1600 finishes ahead of the 9600X. So that, we had already seen it at the time of the test of the 9600X. There were some games where sometimes it was slightly below the 7600. Well, apparently this is the case for Monster Hunter Wilds. I redid the test several times with the two processors. I always arrived at the same conclusion, so it is almost equal, but with a slight plus for the 7600 in this scenario. And it's true that below these two processors there's quite a significant drop. With the Ryzen 5600, the i3-13100 is still struggling to reach an average of 90 FPS, and we can see that in terms of the 1% we're below 60, so it's not great. But we can see that the i3-13100 doesn't seem too penalized with its 4 cores. That wasn't the case, for example, in Kingdom Come Deliverance 2, and we see that in last place, as usual, is the Ryzen 3600, and we see that it reaches an average of 74 FPS. However, in terms of the 1%, we're also well below an average of 60 FPS, so we'll experience drops in FPS below 60. It's happening quite regularly, which isn't great. So in the end, it's still quite catastrophic, I think, in terms of hardware demands compared to what is displayed. The game isn't ugly, but it's not exactly a graphical or technical marvel either. And it's true that there's nothing in the visuals that justifies such heaviness. That's the biggest problem, really. Since when we see cards like the 4070 Super or 7800 XT struggling to reach an average of 60 FPS, in the heavier sequences at 1440p native on a game without ray tracing, you can't help but feel that something's not right. It's even heavier and more demanding than Dragon's Dogma 2. In the end, it was already very, very demanding compared to what was displayed. So, well, I guess it really lacks optimization, and maybe also that the engine is really not adapted to run this type of more open game than more compartmentalized games like Resident Evil or Street Fighter. Since, well, between Dragon's Dogma 2 and Monster Hunter Wild, there are now 2 more open games on this engine that don't really run very, very well. And when you already need a powerhouse to hit 60 FPS at native 1080p in the heaviest parts of the game, I think something's not right. On top of that, not only is the title very demanding in terms of graphics, but also from the perspective of the processor, since processors like the Ryzen 5000 non-X3D equivalents, so everything that is i3, i5, 12th, 13th, and even 14th generation, will be around 100 FPS on average, or even below. We understand why we are strongly encouraged to use frame generation as soon as we launch the game, since it's almost the only way for most setups to hit over 100 FPS. And for many combinations of graphics cards and processors, it will even be complicated, even with frame generation. But the other problem is that frame generation isn't a magic solution for everyone either. When we see that cards like the 3060, 4060, 7600 or the B580 are already struggling to hit 60 FPS at native 1080p, then yes, we can probably hit 60 FPS by pushing a bit on upscaling and enabling frame generation, but it will be far from optimal. I did some tests with the 3060 to reach a level of performance that isn't too crazy. So in the heavier sequences, to enable frame generation, you had to use both FSR in balanced mode, and still, as you can see from the result here, it's not great. I know that a 3060 isn't the most powerful card, but we're talking about 1080p. With FSR in balanced mode, so we're upscaling from 600p, something like that, with frame generation. I'm not sure that Cyberpunk is more demanding than that with ray tracing for the 3060. So here, it's clearly nonsense. Well, maybe patches and drivers will improve things. But given how things went with Dragon's Dogma 2, I don't have much hope that it will improve significantly later on. So, well, aside from having a beast of a setup, it means you're more or less stuck playing with frame generation at a pretty low performance level. So there's a heaviness in the controls and a mush of pixels in the grass, for example, or ghosting, that kind of stuff, as we can see here. For me, there's clearly a problem, and it was pretty much the same during the last playtest. So I don't think it will really be improved for the version that's coming out in a few days. If we're given a benchmarking tool once again before the release, it's supposed to represent the performance of the title. So for me, that's not acceptable, even if the game turns out to be really good in terms of gameplay. It's true that the optimization here is really just awful. And I believe this is the absolute worst example of a game relying on various technologies to run decently that we've seen so far. Not too long ago, we saw games like Horizon Forbidden West, for example, that ran better than this while looking nicer. And even Indiana Jones, with its mandatory hardware ray tracing, runs better than this Monster Hunter Wilds without upscaling or frame generation. So here it's very clear that something's not right. So, despite everything, if you are interested in the game and are tempted to buy it, I would still strongly advise you to use the benchmark exactly to see how it might perform on your setup and whether the result on screen seems okay to you or not. Not to forget, of course, that the result with a controller or keyboard and mouse in hand with frame generation might not be great either, because even if it looks okay visually during the benchmark, in actual gameplay when you're playing yourself, it might not be good either. So anyway, aside from that, not much to say for now. I'll try to see how it performs, I would say, once the game is out. But I'm not expecting miracles, as I just said. Whether it's on the driver side or the game itself, well, otherwise, I think we've covered quite a bit for today. As usual, if you enjoyed the video, the goal-filled stuff on YouTube, it's the build method, the Amazon page of the channel. For examples of typical setups, the current graphics cases and all that, it's in the video description. And as usual, a big thumbs up to the channel's Ko-fi and YouTube supporting members to help it survive. Your contribution is always really appreciated, and we'll see each other very soon for more videos. Sending you kisses. See you next time. Bye.